Let's take a look at solving systems of linear equations by substitution. Step 1 in solving a system by substitution is to solve one of the equations for one of the variables. You're trying to get either x or y by itself in either equation. It doesn't matter which equation, and it doesn't matter whether it's x or y. You're then going to use that expression that either the x or the y was equal to, and you're going to substitute the expression from step 1 into the other equation and solve for the other variable. Step 3, you're going to substitute the value from step 2 into one of the original equations and solve. So in step 2, you either figured out what the value of x was or what the value of y was. Once you know the value of either x or y, you're substituting it back into one of the original equations in order to get the other value. Step 4 is to check to make sure that our solution is correct. We want to substitute the solution back into both equations to make sure that it works in both. Let's take a look at an example to see how this works. So our system is y equals 2x minus 4 and 7x minus 2y equals 5. In this system, we already have an equation solved for one of the variables. This would be a great system to use the substitution method for because you already have a variable by itself. So here we have the y by itself. We know that y is equal to 2x minus 4. What we're then going to do is take this 2x minus 4 expression and we're going to substitute it into y in the second equation. So here's my equation. When I substitute that 2x minus 4 in, now it looks like this. Now I no longer have a y in my equation, I only have x's, so I can solve for x. So here I'm going to distribute. I'll go through my steps. Then I combine my like terms. So I have 3x plus 8 equals 5. I subtract 8 on both sides, and I get 3x is equal to negative 3. I divided by 3, and I get that x is equal to negative 1. So now I know my value for x. I'm going to take my x value and I'm going to substitute it into one of my original equations to solve for y. I've chosen to substitute back into this first equation, y equals 2x minus 4. You could substitute it into the second equation, but it's faster in this particular system to substitute into this first equation because I already have my y by itself. So I'm going to substitute my x. It becomes y equals 2 times negative 1 minus 4, which becomes y equals negative 2 minus 4, which is y equals negative 6. So the solution is negative 1, negative 6. From there, I substituted back into both of my original equations, both my x value and my y value. So here's my y value from the first equation and my x, and I made sure that it worked. And then here's the second equation. I substituted my x value and my y value, and that worked as well. So I know that my solution is correct. Let's take a look at another example. For the second example, I've chosen a word problem. So I had to first come up with a system of equations. So it says you buy a total of 50 turkey burgers and veggie burgers for $90. So it's 50 burgers altogether, and you spent $90. You pay $2 per turkey burger and $1.50 per veggie burger. Write and solve a system of linear equations to find the number x of turkey burgers and the number y of veggie burgers you buy. So I need two equations in my system. Ultimately, I'm trying to figure out how many veggie burgers and how many turkey burgers I bought. So I started with some verbal models. So here's my first system. So the number of turkey burgers plus the number of veggie burgers, when I add them together, will give me the total number of burgers. My second equation is about the price. So whatever the price of a turkey burger is times the number of turkey burgers plus the price of a veggie burger times the number of veggie burgers will give me the total price. So when I take that verbal model and I replace it with numbers and variables, here's the system that I have. X plus y equals 50. This is the turkey burgers plus the veggie burgers. And down here I have $2 times x plus $1.50 times y equals $90. Now that I have my system, I can go ahead and solve it. I'm going to use my substitution method again. Here, because I have coefficients of 1 in this first equation, it makes it easy to solve for either x or y to get it by itself to then substitute into the other equation. So I decided to go with equation 1 and I solved it for x. So I subtracted y on both sides and I got that x is equal to 50 minus y. I could have solved for x. I did solve for x, sorry. I could have solved for y. It wouldn't have made a difference. Okay. I could have solved my second equation for x or y, but this one was easier because these coefficients were 1. So from here I move to my step 2. I'm going to substitute for x in equation 2. So I'm literally taking what x is equal to from equation 1. It's equal to the expression 50 minus y, and I'm substituting that into equation 2. So from here I have all my work shown. I distributed. This became 100 minus 2y plus 1.5y equals 90. I combined my like terms. From here, I subtracted 100 on both sides. I got negative half y equals negative 10 divided by negative half on both sides, and I got y is equal to 20. So now I know my y value. In this case, that y was equal to the number of veggie burgers, so I know that there's 20 veggie burgers. I'm going to take that y and substitute it into one of my original equations to solve for x. Okay, so again, you can decide which equation to substitute for. In this case, my x plus y equals 50. It's much easier to substitute in for to figure out the other value. So I replaced my y with 20, subtracted 20 on both sides, and got that x is equal to 30. So the solution to my system is that you buy 30 turkey burgers and 20 veggie burgers. I would then substitute both of those values back into both of my original equations as my check to make sure that it works. That is how you solve a system of equations through the method of substitution.